We are continuing with this Math 137 review for test number 3. We're ready now for problem 11. Once again, we are solving this equation for the angle theta. And we want to give both the general solution and the specific solution from 0 to 2 pi. Tricky thing here is inside my trig function, I don't have just theta anymore, I have 2 theta. So that changes everything. So with these kinds of problems, the first step is still to go ahead and get the trig function by itself, which I do, but I can't now directly just figure out my angle. I have to do what I'm going to call use substitution. So that's where whatever is inside the trig function, I'm going to call u. So now instead of having cosine of 2 theta, I'm going to replace it with u and have cosine of u equals -1/2. Now, the general solutions for that, now if I say 1 trip around the unit circle, what's the angles where the cosine is -1/2? It's going to be in quadrant 2, 2 pi over 3. And then also in quadrant 3, so you see I've sort of solved this now for u, but of course the original problem, we want to solve it for theta. So once I have solutions for u, I go back to where I first defined u, and I now set u equal to 2 pi or 2 theta, and then I can solve for theta. In other words, u equals this, and u also equals 2 theta. So I can, and now I want to solve for theta. So if I divide both sides by 2, I would have, if I divide this by 2, just get pi over 3 plus pi n. And this second one, if I divide, well, I set it equal to 2 theta. If I divide both sides by 2, I get 2 pi over 3 plus pi n. So I sort of skipped, if you didn't see that. So 2 pi over 3 divided by 2. Actually, I might have messed up. It's a good thing I showed you this. Because this actually should be, let me make sure. Oh, sorry, I wrote this wrong. It's 2 pi. Yeah, I didn't write it wrong. Wow, I'm really. So what happens was the 2 comes into the bottom, and the 2's cancel out. That's how you get pi over 3. And you get 2 pi over 3. So these are my general solutions. So now, for the specific solutions, I start plugging in numbers for n. So when n is 0, I have pi over 3. When I plug n equals 0 down here, I get 2 pi over 3. When I put 1 in here, you get pi plus pi over 3. Well, pi plus pi over 3, you change the pi to 3 pi over 3. Ends up being 4 pi over 3. And once again, all these angles are still between 0 and 2 pi. When I put 1 in for n down here, you get 2 pi over 3 plus pi, which is 5 pi over 3. Now, if I put 2 in for n, hopefully you can see 2 pi plus pi over 3 is going to put you outside of the 0 to 2 pi. And the same thing with the second one. So therefore, that should be the equation for the specific angles between 0 and 2 pi. So the next one, number 12, is sine of 2 theta equals -1. I'm going to redo the same thing I did for number 11. It's going to do a u substitution. Let u equals 2 theta. So sine of u equals -1. So if I solve for u, what's the angle where the sine is -1? There's only one angle. The unit circle where that happens, it's 3 pi over 2. So there's your general, whoops, I'm not done yet because I have to now set that equal to 2 theta. Divide both sides by 2. And you get 3 pi over 4 plus pi n. There's your general solution. So now you start plugging in numbers for n. So if n is 0, you get 3 pi over 4. If n is 1, pi plus 3 pi over 4, it's like 4 pi over 4 plus 3 pi over 4, 7 pi over 4. Once again, if I set n equal to 2, this is going to be larger than 2 pi. So here are the specific solutions. 13 says the sine of theta over 2 equals -√3 over 2. Once again, because my angle is not theta, I'm going to do my u substitution. I'm going to let u equal theta over 2. So now I have sine u equals -√3 over 2. And I have two general solutions. One trip around the unit circle. I'm going to have 7 pi over 6. Whoops, that's not right. I'm going to have 4 pi over 3 plus 2 pi n. And I'm going to have 5 pi over 3 plus 2 pi n. I need to convert them back to theta. Now to get theta by itself, I multiply both sides by 2. So when I do that, I'm going to end up with theta equals 8 pi over 3 plus 4 pi. And theta equals 10 pi over 3 plus 4 pi. So those are my general solutions. Now for specific, I plug in numbers for n. So when I plug in 0 for n, I get 8 pi over 3. But you know what? 8 pi over 3 is larger than 2 pi. So it's outside my allowed values. And also 10 pi over 3 is. So actually, for the specific solutions, there aren't any. all the possible solutions are, oh. But you know what? One thing I also need to check. You also need to put in n for negative numbers. What if I put in -1 for n? Let's just see what happens. 8 pi over 3 minus 4 pi, which is 8 pi over 3 minus 12 pi over 3. Actually, I think the key is probably wrong. Oh, no. The key's okay, because look at, this is -4 pi over 3. And our allowed angles are between 0 and 2 pi. This is a negative angle, so nope. So, yep, no solutions. That's actually correct, but it's always good to check. And then we're the last one of this type on the review. There's one more. Tangent of theta over 2 equals -1. Same thing, that u equals theta over 2. So if tangent of u equals -1, since it's tangent, so I'm going to be one solution. What's the angle? Where the tangent's -1, it's going to be where the sine and the cosine are the same, but different signs. It happens in quadrant 2 and 4. So it's going to be pi over 4. It's going to be quadrant 2 is 3 pi over 4. And the other angle, the other angle is 7 pi over 4. But it's already covered by this. So I set this equal to theta over 2. If I solve for theta, multiply both sides by 2, it's 6 pi over 4 plus 2 pi, which I have to reduce that is a 3 pi over 2 plus 2 pi n. Now, for specific solutions, if n is 0, you get 3 pi over 2, which is okay. If n is 1, it's too big, but there actually is one specific solution for this one. All right, so that finishes up the problems where we're looking at angles rather than just theta. Now, just to show you the next part of the review, we're still solving, we're going to solve these equations now, but we're just looking at the specific solutions between 0 and 2 pi. And you can see these. The good thing is all the trig functions, the angle is just theta. But now we have multiple terms, and usually to solve these, we have to do some algebra kinds of things. Sometimes some factoring, that kind of thing. So some of these we just have to figure out any little kinds of algebra methods we can use to sort of solve them. Just try and do a few of these to start with. So 15 is 2 cosine squared theta plus cosine theta equals 0. Two terms here, set them equals 0, which is a pretty common thing to do when you're trying to solve an equation. I'm going to try and factor. I notice I have a cosine of theta. It's a common factor, so I'm going to factor out a cosine theta. So 2 cosine theta times cosine theta is 2 cosine squared theta. So I factor out cosine theta, and now just like in algebra, when you have two things multiplied together that equals 0, the solution is whenever either one of these factors equals 0. So I take my first factor, I set it equal to 0. And I asked myself, what are the angles between 0 and 2 pi that make this true? Well, where does the cosine equal 0? Equals 0 at pi over 2 and at 3 pi over 2. So those are going to be solutions. So now I take the second, this parenthesis, and I figure out what the solutions for this parenthesis to be equal to 0. If I get cosine of theta by itself, it ends up being cosine of theta equals -1/2. What are the angles between 0 and 2 pi where cosine of theta is -1/2? Well, first of all, in the second quadrant, 2 pi over 3, and then in the third quadrant, 4 pi over 3. So if I didn't mess up, let's actually should have 4 solutions, pi over 2, 3 pi over 2, 2 pi over 3. That is correct. 16. There's actually 2 ways to solve this. You could add 1 to both sides and take the square root of both sides. But I'm going to go and factor because this is a difference of squares. Sine theta plus 1 times sine theta minus 1 equals 0. So once again, 2 factors here multiplied together equals 0. So the solution is to go ahead and take this first parenthesis, set equal to 0, and solve for this, which is going to be sine of theta equals -1. So then you say between 0 and 2 pi, where is the sine of theta equal to -1? Well, it's equal to -1 at 3 pi over 2. They take the second parenthesis, sine of theta minus 1 equals 0. You say sine of theta equals 1. So you say what angle does the sine of theta equal 1 between 0 and 2 pi? And that's pi over 2. So you should have 2 solutions. All right, let me stop now. Turns out I have to do something real quick. I will stop here and then we'll pick up with problem 7.